Okay, welcome back to COC 1436 to the last chapter. We're going to finish the chapter starting with section 9.4, which is what we finished. We finished with 9.3 in the last video. So this video is talking about pointer arithmetic. Let's take a look at pointer arithmetic. Okay, so in this example, we have an array that has 3 elements. And then we have a pointer, an integer pointer that holds the address of where the array begins. So let's say that the address of the 4 was FFE0, for example. Then a val pointer itself would hold this address. Val pointer would hold FFE0. And because I have the little asterisk right here, it means that I'm dereferencing that address, which means that I can get to the first element of the 4 here. So here I'm creating a pointer. It's called val pointer, and it's going to hold the address of vals. And so I'm going to be able to get to this first element just by saying val pointer. I can get to this first element. So in this example, they're doing val pointer plus plus. So if val pointer is here, val pointer plus plus takes me to the next element, takes me to the 7. And then val pointer minus minus is going to take me 1 back. It's going to take me from the 7 back to the 4. So let's take a look at this example. In this example, we're using plus and minus. So here's a plus. And we're adding 2. And notice that we have these parentheses right here. Those are important. So it's going to do what's in parentheses first, and it's going to add 2 to val pointer. So we're going to go from here. So 4 is val pointer plus 1 is 7. Val pointer plus 2 is 11. Sorry about that. And because I have the asterisk, it gives me the 11. Now, if I didn't have the asterisk, it would give me the address, but I have the asterisk, so it gives me the 11. Here I have using plus equals and minus equal pointer and the integer. So the first thing that they do here is we have val pointer equals vals. So remember that vals is the name of the array. So vals has an address. Okay, so val, let's say, has FFE0. So now val pointer has FFE0. So val pointer is starting at the very first element of the array. Val pointer plus equals 2 is going to point to the 11. It's not going to give me the 11. It's just going to point to the 11. Remember, the only way that I can get to that 11 is if I use the asterisk in front of val pointer, and then that means dereferencing. So here in this last one, they're taking val pointer and they're subtracting. They're doing minus val. The value for val. So I think they're saying pointer, subtracting pointer from pointer. Yeah, so I don't really know what this value is. It's just val. But it says it's the difference number of ints between val pointer and val. Well, I don't know what val is. Maybe they meant vowels. Okay, well, let's stop this for a second, and then I want to show you an example using these linear arithmetic. I'm going to use online GDB this time. I know I've been using something different. I am recording new video. And let's see if I can erase all this annotation. Trash, clear. Okay. So I'm going to create an array. And I'm going to assign it 2, 3, 5, 10. Okay, so there's two ways that I can print these values from my array, right? So I can do a loop for int x equals 0, x is less than, so there's 1, 2, 3, 4. I'm going to go from 0 to less than 4. And cout array 1 sub x. So it gives me 2, 3, 5, 10. These are my elements, right? 2, 3, 5, 10. So it's inside the array. Let's do them side by side. 2, 3, 5, 10. Now, if I do the same thing, but this time, instead of using this here, I use address, the address sign. See what we get. Let's put a new line right here. So this is going to give me the address. So all this hex number FBA30 is the address of where the 2 is in memory. And then 4 bytes away, because these are integers, I defined them as integers, then each one of these numbers is going to get 4 bytes. So the 2 is at address blah, 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 30. The next one's at 34, 38, 3C. The reason it's 3C is because this is hex, so it's base 16. So go from 8, right? We're going 4 bytes. So it's 8, 9. So 9, 10, A, B, C. So no, not 9, 10, sorry. Yeah, 9, 10 is A. So let me count that correctly. So after 8, after 38, we're going to go to 9, then A, B, C. So it's 4 bytes away. And we're counting in hex, and that's how you count in hex. So if I make this a double array, then it's going to be 8 bytes. So the 2 is at 70, and the 3 it's at 78. So it's 8 bytes away. So it's in memory, right? The next memory location, because we're talking about arrays. So it's contiguous memory locations. And depending on how you define your array, that's the address that comes next. So an integer would be every 4 bytes. Your number would be put into every 4 bytes. If it's a double, you get 8 bytes. Okay, so I'm going to go back to this being an integer. And the next thing, I'm going to do the same thing, but this time I'm going to use a pointer. So I'm going to create a pointer to this array. So again, remember we're saying int star, and you can name your pointer whatever you want to call it, pointer to array or something. I'll call it PTR, and I'm going to assign it array 1. So remember that array 1 holds the address of the first element. So what array 1 actually contains is this address of the first element. Okay, that's what array 1 contains. And then we're saying, okay, give PTR that address. So let's, before we do this, run it. We don't see anything, but what we can do is we can see out. Let's do it down here. Let's do a see out, just so you can see it. Let's see out array 1 and so this here is array 1. This is PTR. They both contain the same address. So that means that PTR points to the array memory, and I can get to the array by either using the word array 1 or by using PTR. This time I'm going to use PTR because here I printed the content by using the array. Something that you're going to have to do for the exam is step through the array with the pointer. So I'm going to do the same loop. And this time, instead of using array sub x, I'm going to use the pointer, and we'll put x inside. So it's going to be pointer sub 0, sub 1, and actually, so we're going to do. I think I'm going to see it. Do pointer plus plus. So let's do this first. So 0 to less than 4, and see what it prints out. Okay, so here this first one prints out the contents right here. The second one prints out the address. And this one also prints out the address, but notice it's printing out the address of each element. Now, if I put the little asterisk right here, I'm going to get the contents. So the asterisk is what dereferences the pointer. So dereferencing means don't give me the address, give me what the address points to. How I can step through. That's what they call pointer arithmetic. So this increases by 1 every time. And it's like doing this right here, increasing. This is increasing by 1 every time. Sorry, this right here. So let's take a look at this example. They have, just 1 second. There's something on my screen you don't see, but it says bar, the zoom bar that I have to move away. Okay, so we have this array called set, and this array is of size 8. It has 1, 2, 3, 4, 5, 6, 7, 8 elements. Remember, we can access these elements from 0 to 7. Here is a pointer. And they just set it to null, so they set it to no address. And then, right here, they say set num pointer equals set. So at this point is where now num pointer and set both point to, they both point, why is it going backwards? Both point to this 5 right here, to the first element of the array. So number and set point to the 5. And it says use the pointer to display the array contents. So again, we know we're displaying the array contents because we have this asterisk right here. This dereferences our pointer. We're starting at 0, less than size is 8, so 0 to 7, cout, pointer, num pointer. So this dereferences, so the first time it's gonna, num pointer is pointing to the 5, it's gonna point to that. I keep pressing something. Okay, the first time num pointer is pointing to the 5, so it's going to dereference the address and give us the 5. It's going to increase by 1, so now it's going to go to the 10, and it's going to print the 10. Without that asterisk, again, it's going to print the address of each of these instead of the value. And then here it says display the array in reverse order. So we start at 0, same loop from 0 to 7, except we're doing num pointer minus minus. So at this point, when this loop finished, it was pointing to the address after the 40. So it does a minus minus first to get us back to the 40, and then it prints the 40. So the only reason this works is because this one was finished. And where pointer was at that point when it finished, it was here. So let me just draw this. So it was like, if you're looking at these in memory, the pointer was pointing to this memory location. Of course, nothing exists there in that memory location. So this line first takes it back 1, and then this line prints the 40. And then it goes back in and it moves back 1, prints the 35. So type this one in, try it out, make sure that you understand how to iterate through an array with a pointer, because there will be questions on your final. Definitely there'll be questions. And I do have on Canvas, I have a practice quiz just on pointers, because there will be some difficult questions about pointers, and I want to make sure that you're ready for those pointer questions. So study hard on the pointers. Okay, let me trash this. All right, so initializing pointers. All right, so let's see what we have here. It says we can initialize at definition time. So there's different ways, I guess they're saying that you can initialize. So here we have int num, we just have a plain number. And we can say star num pointer equals the address of num. So that's one way to initialize it. So this here is this num pointer is pointing to whatever the address of num is. So they're both, so it looks like this. So if you have num, and num has address. I'm just going to write the last 2 letters so I don't have to write too much. So, it's going to be a big hexadecimal number. Let's say it ends in FE. The num pointer contains that address, FE, blah, 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 FE. So that's why we say that num pointer is pointing to none, because it's pointing, because it contains the address. And then here we have an array that has 3 elements. And so we say pointer, val pointer. Okay, so we're creating this val pointer integer. This is, I don't like the way they're doing this, but basically they're saying int pointer val pointer equals val. So it's like saying this. They're putting it all together, which is hard to understand. Pointer val pointer equals, and val's the array right here. So what this points to the first element in the array. So if we have an array with 3 elements, this points to the first guy. So you can get to that first element through val sub 0 or through val pointer, asterisk val pointer. Cannot mix data types. So here we have double cost, and here you making an in pointer. This needs to be a double because you are pointing to a double. So your pointer has to hold the address to a double. Okay. Can test for an invalid address of pointer. So this right here, what it does is it tests to see, to make sure that you are pointing to something. So let's say that you create a pointer and you assign it null pointer. When you do not pointer, it's going to tell you that true, I'm not pointing to anything. So you can test to make sure that your pointer is pointing to something. So let's try this one right here. So we have a pointer already. So we can say if not pointer, yeah, not my pointer is not pointing to anything. It's null, basically. So my pointer is pointing to something, so it's fine. But let's say, let's move this to the bottom. And let's assign pointer. Pointer equals null pointer. So now it says my pointer is not pointing to anything. That's because I set it to null. And so now at this point down here, it's set to nothing. Up here, it's fine. But then here, I get to here and I null it out just to test this. My pointer is not pointing to anything. Okay, so that's testing to make sure that you are pointing to something. And again, if you're not sure that you did it correctly, I would just do a cout. Like I would cout array 1, a cout PTR without the asterisk, and you should have the same address for both of them. Comparing pointers, we can compare pointers. So this right here compares the address of the pointers. This right here compares what's in what the pointers are pointing to, the contents of the pointers. So here, remember, if you have the star, it means you're getting to the value, to the 2, 3, 5, 10. Don't have the star, then it's showing you, it's what it's comparing is these addresses. So if you say, is PTR equal, PTR would be 2 equal to PTR plus 1, it's looking at the addresses. And now let's say the contents were the same, like 3, 3. It's not looking at the contents. So let's do that. So let's say that we have a 3 here and a 3 here. We can say if pointer is equal to star pointer plus 1. And FCL LCL not equal didn't do a new line. So it's going to say equal right here. That's because the 3 and the 3 are equal to each other. So I can say star pointer is equal to star pointer asterisk pointer plus 1 sound star stroke. And line. So it's not all like bunched up. So it says 3 is equal to 3. So that's how I can get to, and this, I can compare them with the equal sign. Again, it's comparing the 3 and the 3, it's not comparing the address. Now, if I take the asterisk out, then it's comparing the address. And it's going to say it's not equal because, of course, the addresses are not equal. Let me take out the asterisk. So it says not equal. So it gives me this. This doesn't matter since. Okay, so this is looking at address. This address is not equal to this address. Okay, I'm going to put it back the correct way. And again, I need the parentheses here because I have to add 1 to the pointer and then dereference it. So if I don't do that, by the way, so I want to show you if I take out these parentheses, let me show you what happens. You might be able to guess what happens, right? So here, the asterisk is going to go with the pointer. So it's going to dereference the pointer. So it's going to get the value of 3, and then it's going to add 1. So it's going to print a 4. So it says 3 is equal to 4 because this right here got this 3. Actually, it didn't get that 3, it got this 3 right here. So this is this first 3, and then we add 1 to that first 3. So those parentheses are pretty important. All right. That's comparing. And then pointers as function parameters. So a pointer can be a parameter. It works like reference variables to allow change to argument from within the function. It requires the asterisk in the parameters, prototype, and the heading. So here in this line, we see the prototype. It has an asterisk. Oops. Has an asterisk. And then the asterisk in body to dereference the pointer. This dereferences the pointer, like we said earlier. It gets us to be able to get the contents of what the pointer is pointing to. Here they're doing a CN. That means that they're going to write something into whatever it's pointing to. Address as argument to the function. So if you are working with a pointer like this, then what you pass as an argument has to be an address. So it can be address num, or maybe it's an array. If it's an array, you just give it the name of the array, because the name of the array is an address. So here they have this function swap. X is a pointer, Y is a pointer. Here's where we call the function swap. So we have num1 has the value of 2, num2 has the value of -3. Okay. So the address of num1 is what we pass to here. All right, so let's just draw this. Sorry, I didn't mean to make these. Here, hold on. Let's draw them down here. Okay, so I create two variables, two integers, 1 and 2. And this is num1, 2. This contains a 2, and this contains a -3. Okay, then it says pass the address of num1. So let's say the address is E0, and this is E4. Okay, so the address of num1 gets passed to X. So this pointer contains E0. That's the address, and then E4. Notice that these pointers are integers only because num1 and num2 are integers. So the data types have to match. Okay, so now see, I'll put X here. X is pointing to num1 and Y is pointing to num2. So then they create this variable temp. They dereference X. So by dereference X, they get the 2. The 2 goes into temp. Dereference Y. Y is pointing to the -3. So this has a -3 now. So what happens here, we're putting a -3 into what X is pointing to. X is pointing to here. So num1 also changes to a -3. And then temp, which has a 2, gets put into what Y is pointing to. So the 2 gets put here because Y is pointing to num2. So it swapped num1 and num2. The num1 now contains the 3 and num2 contains the 2 by using pointers. So I would also enter this into the computer, run it, make sure you understand how it works. I would do a cout here, cout num1 and num2, so you can see how they got swapped. You could see out X and this star X and star Y, so you can see that they have the same values as num1 and num2. All that kind of stuff would be good. Just talking more about function parameters. In this example, we have get number, double val. They're both both functions are gonna have one parameter, and they're both integer parameters. So because they're integer pointer parameters. So because they're both integer pointer parameters, we have to pass the address of something to these pointers. So here they're passing the address of number. Here are the function definitions. Again, the header matches the prototype, int pointer, int pointer. It does not have to have the name of the variable. And here we're also receiving the address. So once again, the address of number, FFE0, whatever the address is, gets passed to this pointer input. So input now holds that address and it points to the same thing that that number points to, both of these. So it says enter an integer number. Here, let's see what it says now. Enter integer number. So when the user enters a number, they enter a 10 right here for input, then it's also changing this variable number. So at this point, we have a 10 also. And then we pass the address of number to here. So val also is pointing to the 10. And then here we multiply the value in val, which is 10 times 2, and assign it back to val. So val has a 10, and then number gets changed to 10. This is quite complex, sort of. But basically what it's saying is that the address of number is the same as the address of this guy and of this guy. So they all point to the same thing. So anything you do to those variables are going to change number. This original this variable right here. Okay. We'll look at that in a second. Let's take a look at a function. Okay, so let's say I have this array. Create a function here. Void function 1. Programming Java too much. Okay, and then what I'm going to do is I'm going to pass, I want a pointer here, int pointer. And what I want to pass to this pointer is I'm going to pass function 1. I'm going to pass array 1. Now, because I'm passing array 1, that name holds an address. I don't need the address sign. Don't put an address sign there. It's going to break. Now, let's say that I'm going to use something different, like a double num1 equals 10.9. Now let's say I have function 2. I haven't created function 2 yet, but I will in just a second. So function 2, let's say that what I want to do with function 2 is also receive a pointer, but this time double pointer. So here, because this is a variable, I have to pass the address of num. Because this is an array, I don't put the M sign because the names of arrays always contain the address of what the first element points to. That's what arrays do. So here, oh, I need some prototypes. That prototype. And again, I can keep PTR or I can leave it out. It does not matter. See if I made any errors. This is num1, this is num1. Okay, so my program's not doing anything because my functions are not doing anything, but they're working. And what I can do to make sure that I pass the right things here in function 1, I'm getting the array. I could just see out star pointer, and that would give me the first value of the array, which is a 3. Here, I can see out star pointer, and it would give me the 10.9. So dereference the pointers, what this is called, dereferencing the pointer. So I can see the value 3 and 10.9. Again, this gives me 10.9 because it's pointing to num1. This is pointing to this first one. If I want to see this last one, it would be +1, +2, +3. +3. So this is PTR, PTR +1, oops, PTR, PTR +1, PTR +2, PTR +3. All right, so also type that in, run it, and then make sure you understand how this works. You have to be able to process this on your own and really study it. Read the book. Don't skip reading the book. If we want to store the address of a constant in a pointer, the address of a constant. So you create a constant and you want to get the address of that constant, put in a pointer. Then we need to store in a pointer the constant. Okay, let's see what that looks like. So here's a constant, size 6. Here's a const double pay rate size. So in this case, it says pay rate is an array of constant doubles. So pay rates is an array of constants, which means that I can't change these values. So then it says, suppose we wish to pass the pay rates array to a function. Here's an example of how we can do it. So to pass the pay rates to a function, we can create a constant double pointer. Const double pointer rates. So this is what rates is going to point to. Let's see. I was hoping they would show the call to the function. I don't see the call to the function. So this is the function itself. And here we have const double rates. So we would just pass it this array. Okay, so I think I know what it's saying. So it's saying the array has been defined here as a constant. So then when you make the definition of the function right here, this has to be constants also. Okay, constant pointer is a pointer that is initialized with an address and cannot point to anything else. So here's an example, int value 22, int star const pointer equals address of value. So this constant pointer right here can only point to this 22 and nothing else. So we can't change it later on, is what it's saying. We can't say, oh, let's change what pointer is pointing to, change it to some other variable. So it says the asterisk const, this part right here indicates that the pointer is a constant pointer. This part over here, this is what pointer points to. It's pointing to a constant integer. So if I wanted to point to a double, it would be const double star const pointer. If I wanted to point to a string or a character, it'd be like const character star const pointer. So again, pointer const indicates that this pointer is going to be a constant pointer, and this indicates what I'm pointing to. And let's just do that in an example. For example, here we have a double. So if I wanted to create a, so this is double num1. So let's make this a constant. the first, I'm gonna make a const pointer. Like that. And then I'm gonna say, what is this gonna point to? Well, let's have it point to sorry. Put double. So here we put const double. Constant double. Oh, we're gonna put pointer first, sorry. And pointers to constants very often. So const double, this tells me that I'm going to be pointing to a constant, and this tell me is going to be a constant pointer. Okay, and let's see if it allows me to do this. Address num1. I'm trying to pass num1 here. Let's not call the function. Let's not do that right now. Yep. Okay, so this pointer PTR is pointing to the address of num1. Now let's see if I take out this const here. This works. Yeah, it still works. So what this is going to do is what I can point to anything, whether it's a constant or not, but it means that I cannot redefine this pointer. Like, let's say that I have num2 equals 11.0. So I can't say pointer equals address of num2 because PTR is a constant. So it won't let me do that. It says assignment of read-only variable pointer. It's a constant. So I can only read from it. I can't reassign it. Okay, so I've got two numbers. This is a lot to create your pointer. Let's just end it right here. You can say PTR equals num1. Let's see if it allows it to do that. No. So it has to be initialized at the point that you create it. So it doesn't allow me to initialize it later. I have to initialize it here, meaning I have to give it an address. So once I initialize it, give it the value, the address of num1, I can't then go and change it. I can't do PTR equals. Okay, so that's constant pointers. Dynamic memory allocation. So dynamic memory allocation means that you're allocating memory as the program is running. So whenever you create an array, like here, this means it's static memory allocation. Static memory allocation. So the memory is already allocated. We know exactly how much room this array is going to take. So as the program starts to run, it's just 4 elements, that's it. And each element is, since an integer is 4 bytes, so 4, 8, 16 total bytes this is going to take. So this is not, we're not allocating as we go. We are so close. Okay, so 9. So to declare a memory as you're running a program, So it says, can allocate storage for a variable while the program is running. That's dynamic. The computer returns the address of newly allocated variable. We have to use the new operator. So anytime you use new, you're allocating memory as you're running the program. So we would say double star, double pointer. So we have a pointer that's going to be pointing to a variable that holds a double. We null it out, so it's pointing to nothing. Then here we say double pointer equals new double. So what this does is when the program runs, then it finds 8 bytes of memory and it allocates that address of those 8 bytes to the pointer during runtime, just by using the word new. And that's what that says right there. It says can also use new to allocate an array. So we can say, here's the size of the array, 25. You can say array pointer equals new double size. Now you have to, so array pointer is just a name you created. You could have called it Bob. So you could say Bob equals new double size, okay? So now that word Bob points to the first element of this array. So here, once you do this part, you can either iterate through the array with the pointer and the square brackets, or you can iterate through the array by doing the plus I and the little and the asterisk. So dereferencing like this or like this. It says the program will terminate if not enough memory is available to allocate. So let's say that you try to allocate a, let's say here instead of 25, you have, I don't know, something really large. And as you're running, you just don't have enough memory to allocate to that array, then the program's going to terminate. These days, our computers, our desktops, our laptops, we have tons and tons of memory, so that will usually not happen. And we're not going to have huge arrays. Okay, so in that Canvas quiz, there's going to be a lot of practice too doing this right here. So allocating a dynamic, doing memory allocation dynamically, just using the new, and then iterating through the array to, here we're putting values into the array, here we're also putting values into the array. We're just doing it 2 different ways. Now, once you create something dynamically, once you're done with our array, you want to release that memory and so they can be used by your program or other programs. So you're going to use delete to free up that dynamic memory that you allocated. So you delete the pointer. Use delete to free, so we use it like this. And we use it like this if it's an array. So this is just a pointer, this is a float pointer, just pointing to one variable. The second bullet here is pointing to an array. And again, only use delete with dynamic memory. This is an example that's in your book, and I would definitely type up this example and run through the example because it creates an array. If you notice here, it creates an array using new. So it asks us, how many days of sales amounts do you wish to process? Num days. Then it uses new here to allocate that many number of sales amounts. So let's say that you have 20 days, then it would dynamically have a 20 there, and it would create, since these are double, it would create 28 byte memory locations contiguous right next to each other. So FFE0, FFE8, FFE, FFE, FF10. I'm trying to add in hex, it's hard, but it would go by eights. So that's done U right there. And so in this program, even though we created the array with dynamic memory, they're using the old-fashioned way to get to the elements, which you can, like this. But down here, they're freeing up the dynamically allocated memory. So they delete square bracket sales, that's the dynamic array. There's the dynamic array right here. Sales. And then they did sales equals null pointer. And it says it makes the sales a null pointer. So now sales doesn't point to anything. So it's freed. So here, we're just going through the array the old-fashioned way. We're not using pointers, but we could actually go through it by using a pointer. Let's see if it gives you an example of that. No, it doesn't. Okay, and then the last section is returning pointers from functions. So pointers can be returned. Pointers can be the return type of a function. So here's an example here on the left-hand side, int pointer. So we know that we're going to be returning a pointer from the function. So let's take a look at this example. We have int pointer down here, returns ARR. So this right here has to match this data type, right? So ARR is an int pointer. That's all that you want to be aware of in this particular slide. So here they have a pointer called ARR. They dynamically allocate an array. So it's getting past a certain number. Let's say it gets past a 5. Then this array is going to be size 5. Dynamically, it's going to create an array of size 5. And then here, it populates the array. So it looks like it's putting into the array 5 random numbers. And then it returns the pointer to this array. So wherever it returns it to, it's going to point to this array that we created here. And it'll be able to get the values, those random values. And then using some smart pointers to avoid memory leaks. Memory leaks is things like when you try to get to addresses that you haven't allocated any memory for. So it says in C++11, you can use smart pointers to dynamically allocate memory and not worry about deleting the memory when you are finished using it. 3 types of smart pointers: unique, shared, and weak. You must include the header file memory. And in this book, you're only introduced to the unique pointer. So it says unique pointer int, pointer new int. So what this takes the place of is it takes the place of doing int so this, you would do all this instead of doing this to create your pointer. So here, this here tells us that the data type that the pointer will point to is going to be an integer. So that would be this left-hand side here. This is the name of the pointer. That would be the old-fashioned way, would be this. And uint actually dynamically allocates the memory. So it does it while you're running the program. We're not assigning any values to here. We're just allocating memory for the int pointer. This is the expression uint allocates a chunk of memory to hold an integer. The address of the chunk of memory will be assigned to pointer. So at some point you would say pointer equals, and then assign it the address of something. And then it would be a smart pointer. Here. So again, it says to start it in version 11 of C++, you can dynamically allocate memory for your pointer. And you don't have to worry about deleting the memory when you're finished. So when you're finished using it, it will delete the memory for you. So that's nice. You won't have a bunch of pointers out there that aren't being used. Okay, that's the end of this chapter. Make sure you go to Canvas and look at the practice for this chapter. It's a practice Canvas quiz. It'll say practice pointers or something. It has a lot of questions. You have to be fully prepared for this final exam because it's going to have some hard pointer questions. So make sure and review those. Okay. Thank you guys. I enjoyed teaching this class. Make sure that you email me as you're finishing everything up. If you have any questions, don't hesitate to email me.